so on to learning goal 3, and this one is building upon what we've already learned from 1 and 2, and this time it is I can write and evaluate expressions that contain variables. So there's a couple new vocab words that we want to talk about. The first one is a variable, and a variable is just an unknown number.
And that could be any letter. You might see it as a letter in there, like an R or a P or a Q or a T.
Mm-hmm.
Any of those are considered variables.
Yes. So maybe you can even mention can look like a letter in different expressions. And we'll show you what that means in just a moment. And then the other word that we want you to be aware of is evaluate and what that actually means. And this is what we're going to be doing. It is where you substitute a value for a variable. And once again, it'll probably make more sense once you actually see it. So we have here an expression. The variable in this case is the letter P, so you can also label that so you can sort of see it in the actual problem or expression. And then the actual expression, as you remember from before, is this little section right here. And remember, it doesn't have an equal sign, it's just expressing the different symbols and numbers here. So this new part is right here we have the letter P equals 10, and so that is what we use to evaluate.
And we'll give you some examples on how to actually evaluate these in just a second.
There. So if you need to pause, go ahead and do that just to make sure you have your notes that will come in handy.
Yep. Okay, so our first of our examples, and I'll just write it out first. The one that you just had up there, actually. So we're going to actually evaluate it. So for the first one, we have our P equals 10. So all that means is I'm going to use this to substitute into that missing variable. So if P equals 10, then I can replace this P with the 10. So this becomes 5 times 10 minus 2. Now, to evaluate it, all I have to do is simplify my equation. So again, using that PEMDAS like we've used before. We're not going to write it all out again, but if you need to, please do. 10 minus 2 is 8. I do my parentheses first. Then there's no exponents, so now I look at multiplying. And 8 times 5 is 40. So that is my first example of how to evaluate an expression. So the second one, Mrs. Van Dam is going to go through. I'm just going to write it down.
Thank you.
Catches her breath. There we go.
And some of you might think, oh my goodness, because if we look here, we have a fraction, but we can still do the exact same thing. We are going to replace this x with this fraction. So now we will have 5 divided by, instead of x, we're going to just replace it with 1/3. Now some of you might think, but we've already done fractions. Yes, but we get to do them again. And now it's a fun review. We can think, oh yeah, when we were dividing fractions, we remembered the keep, change, flip idea. So
I'm certain they're all just as excited.
I know, they're so excited. Keep, so we're going to keep the 5, and we talked about how you can make that into a fraction if that helps you. So 5 over 1. And then we're going to keep and then change this into multiplication symbol now. And then we flip the second variable, so we have 3 over 1 instead of 1/3. So now I just have to remember how to multiply fractions, and that's where I multiply across the numerators. 5 times 3 equals 15, and then multiply the denominators going across. 1 times 1 is 1, and 15 over 1, as you know, equals 15.
Yep. Now we're on to our pause and try it section. So go ahead and give that a try. I better draw this line so Mrs. Van Dam has a place to do her example next.
Ooh, yikes. Yeah.
Okay, so hopefully you've given this a shot. Now all I need to do is substitute in my D first. So I'm going to leave everything else the same. and I'm going to plug in 3.5 where the letter D was. Now I just go through and solve. So parentheses first. 3.5 minus 2.5 is simply 1. Now I'm going to write the rest of it out. Well, now, this is pretty easy peasy. I thought it was going to be a lot harder. 7.5 times 1 is just 7.5. So there's my answer. So our next part is being able to take that information and apply it to some real-world situations. So we're going to do an example. You do not need to write out all of these words, but you do need to write down the stuff that we write down as far as the equation goes. So if we have the real world problem, okay, so there are 2/3 as many students in science club as math club. If there are m number of students in the math club, how many students are there in the science club? So in my head, I think, okay, there's 2/3 as many, or 2/3 of the math club. So of, if I remember, I'm thinking 2/3 of m, and when I think back to multiplying fractions, I always remember the big thing we talked about was that of means multiply.
Yes.
So if I was going to write this expression, it would be 2/3 times m is the total number of people in the science club. So then you're going to take that and look at, okay, if there's 27 students in the math club, what I'm essentially saying is my m is 27. So if my m is 27, how many are there in science? So now I'm going to use the expression I just wrote to solve it. So this becomes 2/3 times 27, and I tend to automatically just put it over 1 when I'm multiplying fractions.
Yeah.
Now I look at this, I can try and multiply 2 times 27, but I like to not have to simplify later, so I'm going to simplify it first. I know both of these have 3 as a factor, so 27 divided by 3 is 9, 3 divided by 3 is 1. So when I multiply this across, I end up with 8 over 1, or 18, sorry. Which means how many are in science? 18 students. Now, I want to stop and think about this and make sure that my answer actually makes sense. That's really helpful sometimes when you're doing story problems. If up here, 2/3 as many students are in science, that means there are less students in science, right? 2/3 is less than a whole. So my answer should be less than the math club. So if there's 27 in the math club, I have 18 students in the science club, then that would be correct. So now is you try it, or a pause and try it, and then Mrs. Van Dam will go over this one. So go ahead, you don't have to write all this down, but put like 3A and 3B and try and do that.
So, reading here, to change temperature from Celsius to Fahrenheit, multiply it by 9/5, then add 32. So, some of you might have always wondered, well, what is the difference between Celsius and Fahrenheit? And maybe this will make more sense. So looking here to begin with, says let C be a temperature in degrees Celsius. Write an expression for changing Celsius to degrees Fahrenheit. So we want to think about here multiplying to change temperature from Celsius to Fahrenheit, multiply it by 9/5, then add 32. So we are going to look at, for changing Fahrenheit, so then use your expression to change 20 degrees Celsius to Fahrenheit degrees. So if you didn't get this first part correct, now you can still pause and try it now that you do see the correct expression here. And now you would just replace the C, Celsius, for 20.
Yep.
So we would then look at 9/5 times Celsius, 20, or we can do 20 over 1. And then we're going to add 32. So looking here, once again, I also like to simplify first. It just helps with smaller numbers. So I can see here that 5 can go into 20. Both can be divided by 5. 5 divided by 5 is 1. 20 divided by 5 is 4. So now I get 9 times 4 is 36 over 1, which really equals 36 again. And then I get to add this remaining part here. So 36 plus 32 is going to equal 68 degrees Fahrenheit this time. I started with 20 degrees Celsius, and now when I go through this expression, I find out that that would equal 68 degrees in Fahrenheit.
Very good.
Toughy,
okay.
But hopefully that works.
Now you've got 5 questions to solve on your own. And I'll put these up here, and you're going to probably need to pause it to go back because there's also a story problem that goes with it. So we've got these 4 that are simply using these variables in here to help you to substitute in to solve it. Then 5, look how long it is. Okay, Kim's rabbit weighs 6 pounds more than her, Kim's cat weighs 6 pounds more than her rabbit. Her dog weighs 3 times as much as her cat. Let R be the weight of her rabbit. So you need to use that information, and think of it like a mystery because you can't figure this out. How much does the cat weigh? How much does the dog weigh? If a rabbit weighs 5, how much do her cat and dog weigh? So these ones you will have variables in there. Okay? This one, right?
Mm-hmm.
This one you'll be able to actually figure out an example or an exact amount. Then, so like these ones you'll have the letter R somewhere in your equation. And then your guiding question to answer is, in words, explain how you would solve the following problem. So you have this problem here, m equals 10. In words, tell me what you would do to solve that if you had to like explain it to someone else. So good luck. We'll go over these tomorrow.